For this next item, let's evaluate the integral of z squared sine 4z dz from 0 to 2 pi. Noticeably, we have here sets of functions on our integral. That would mean we are going to introduce here integration by parts. You have here the integral of your z squared sine 4z dz from 0 to 2 pi. Allow me to add another page if necessary later on, and this video might be very long. Allow me to discuss this thoroughly as we need to talk about certain steps that will allow us to find the result of this. Take note, we have here a trigonometric function. If we're going to look at sine of u du, your du would not contain z squared. In short, it cannot be used for that. Similarly, if you're going to stick with z squared following the form of u to the n du, your n will no longer, there's no possibility for that to become trigonometric function. Hence, obviously, at this time, we are going to use here integration by parts. Don't forget about the mnemonic Liate, which allows us to pick the necessary functions for our integration by parts. This means this could be u dv equivalent to uv minus the integral of v du. We need to find the appropriate u to get our du, and the remaining functions would be dv to get our v. Again, according to Liate, we're going to prioritize algebraic function z squared than trigonometric function sine in that specific order. That would mean let me use here the white one. Let u be z squared. That would mean your du needed for this is equal to 2z dz. If we let this being our u, that would mean the entire remaining functions inside would be our dv. So we have here our dv is sine 4z dz. To get the v, let's integrate that. So the integral of sine 4z dz would need us to include here a certain constant. That's 4 because we need to have sine u du. So we'll have here the integral of sine 4z 4 dz. We're adding this. So to neutralize that, we need to place here 1/4 so that we are not necessarily changing the entire expression. This would give us our v equivalent to 1/4 times the integral of sine 4z, which is actually negative cosine 4z. So in short, our v is negative 1/4 cosine of 4z. These are the items we need to introduce here as we write this given expression in terms of this red one using integration by parts. Our u, v, so our u is z squared. Our v is negative 1/4 cosine 4z. But this will be evaluated from 0 to 2 pi as indicated in the given. Minus v du, the integral of v, negative 1/4. Sorry, let me rewrite that. That's 1/4 cosine of 4z. That's v. Your du is this times 2z dz. Okay? This is 0 to 2 pi. Let us not substitute the limits for our first form because we are yet to identify whether this is good or not. Allow us to just manipulate that in this manner where we take the negative 1/4 first. Negative 1/4 of z squared cosine 4z, and then this one here, take out negative 1/4. That means you have plus 1/4. Take note this is from 0 to 2 pi. The integral from 0 to 2 pi of your cosine 4z 2z dz. Okay? So that is for our next one. By the way, I can move out this 2. Okay? I can move out 2 because that's also a constant, making this 2/4, or basically That is equivalent to 1/2, right? So making it 1/2, the 2 earlier will no longer be there. So ZDZ. These are all possible because we have here 1/2 earlier, 1/4 rather, and you have here the 2 which we moved out, right? Now, when you look into this is still non-integrable because we have here another function z. Hence, we will introduce here another set of integration by parts. But this time, we will also be using this u sub 2. Not to be confused with the first u we used earlier. I could label this sub 1s, but not to be confused with what we already did. Let's have the u sub 2. U sub 2 is just your z. So your du sub 2 is dz. Okay? So we have this one. In short, this together with that comprises your dv sub 2. dv sub 2 is cosine 4z dz. To solve for v sub 2, so to integrate that, cosine of 4z dz. Now, similar as earlier, so for us to be able to integrate that, we need this constant 4 here and neutralize that with 1/4 outside. So this is 1/4 integral of cosine 4z for dz. This means your v sub 2, now that is good, it follows cosine u du, is 1/4. The integral of cosine 4z is sine 4z. That's the item we need to introduce here. Now, take note, the first term would still be negative 1/4 z squared cosine of 4z from 0 to 2 pi. You have here plus, you have here a factor of 1/2. Please not forget that. And then your u, because it follows uv minus integral of v du. Your u is z, okay? Z times your v sub 2, which is 1/4 sine 4z. This would be to be evaluated from 0 to 2 pi minus the integral of v 1/4 sine of 4z and then du dz from 0 to 2 pi. These are all under the same factor of 1/2. Now, allow me to lay them down here in just one line, and I might need another page for this because I need to really work this out step by step without possibly removing all forms of terms. So you have here plus, rearranging this one. Well, still I'm gonna have 1/2, gonna multiply 1/2 later on. So 1/4 z sine of 4z from 0 to 2 pi. Then you have here, let me take out 1/4 minus 1/4, the integral from 0 to 2 pi of your sine 4z dz. Okay? These are all again the product of 1/2. We're doing this because same as earlier, I need to add here 4. So I'm gonna multiply here 1/4. But since there's already another 1/4 there, so notice that what will happen to the coefficients. This is still negative 1/4 z squared cosine of 4z 0 to 2 pi. Still a factor of 1/2, 1/4 z sine of 4z from 0 to 2 pi. This time, originally it has 1/4. I'm gonna multiply another 1/4, 0 to 2 pi, so that I could introduce here 4 dz. Right? So this is negative 1/4 z squared cosine of 4z, still 0 to 2 pi, plus again 1/4, a factor of that, 1/2 rather, times 1/4 z sine of 4z 0 to 2 pi. Then this becomes 1/16. Okay, 1/16. That's minus times the integral of sine 4z. We cannot integrate that. The result for it is negative cosine 4z 0 to 2 pi. Okay, so allow me to copy this and then add another page. Okay, this one here. So multiplying this first here before I will distribute 1/2. Negative 1/4 z squared cosine of 4z is 0 to 2 pi. That's 2 pi. Plus, again, let's stick with 1/2 first. 1/4 z sine of 4z is 0 to 2 pi. This is still 2 pi. Minus 1 over 16. It becomes plus now. Negative times negative. Cosine of 4z is 0 to 2 pi. Before substituting the limits, allow me to distribute the 1/2 now. Negative 1/4 z squared cosine of 4z is 0 to 2 pi. Okay? Plus 1/2 times 1/4 is 1/8 z sine of 4z. 1/2 times 1 over 16 is 1 over 32 cosine 4z. Sorry, this is 0 to 2 pi, 0 to 2 pi. Okay. Now, let's substitute the limits, upper limits, and minus the result for substituting lower limits step by step. So, this is what will happen here for the first term. Negative 1/2 2 pi squared cosine of 4 times 2 pi minus, since it's preceded by a minus sign, I'm going to use the grouping symbol, negative 1/4 is 0 squared cosine of 4 times 0. Now, grouping symbol might not be needed for some because this is still 0, but allow me to do that to be consistent with the correct process. This is just for the first term. For the second term, plus 1/8, you have your 2 pi for your z, sine 4 times 2 pi, minus 1/8, 0 times 0, times sine 4 times 0. That's for the second term. For the third term, involving 1 over 32, 1 over 32 of your cosine of 4 times 2 pi, that's your z, right? Upper boundary, minus 1 over 32 cosine of 4 times 0. Okay, now, this has 0 factor, so that's entirely 0. This is also 0 factor, so that's 0. Cosine 4 times 0 or cosine 0 is 1. So it stays as it is. Don't forget about that. So let's have here negative 1/4 pi, the square of 2 pi is 4 pi squared. Then you have here the cosine of 8 pi. Plus, we have here 1/8, this one here, times 2 is now 1/4. 1/4 pi, then sine of 8 pi. Then, plus 1 over 32 cosine of 8 pi minus 1 over 32 cosine of 0. Okay? So this is that, and that's the next one. Okay. What is cosine of 8 pi? That's actually 4 revolutions in a unit circle. It returns to the original point of cosine 0, which is 1. Right? So cosine 8 pi, you have here 2 pi, 4 pi, 6 pi, 8 pi. This point here is, of course, we know that, okay, to be cosine of 0, which is 1. So this means, as I cancel this, I have here negative pi squared times 1. Sine of 8 pi is actually 0. So that's 1 plus 1/4 pi times 0. Plus 1 over 32. Again, cosine of 8 pi is actually 1 minus 1 over 32, and cosine of 0 is also 1. This means I have negative pi squared. This becomes 0, and this 2 becomes 0. So that would mean the final answer, finally, for this very long process involving 2 sets of integration by parts, is actually negative pi squared. This is the integral of z squared sine 4z dz from 0 to 2 pi. Again, the answer is negative pi squared. Thank you very much for watching.